a container with some water inside. Let's have some water here. Okay. So water there. Now I want to find the pressure of this water at the bottom of this container. So because of the weight of this water, okay, then there would be a force from the weight pressing down at the bottom of this container, and I'm interested to find the pressure. So let me write down the formula for pressure. Now pressure is equal to the force divided by the area. Okay, so force in this case would be, for example, the force from the water pressing down, and the area would be the area of the bottom of the container. And okay, so let's now think of some example, some numbers to try and find the answer for this. Right. Let's say that the volume. We need the volume. Let's say the volume is maybe 0.1 meter cubed. 0.1 meter cubed. Yeah, that's a lot of water actually, but never mind. Let's say that's the thing. And no, maybe that's not the number that I want to take. Let me do the numbers. Think of the description in another way. Instead of using the volume, I'll describe this using the heights. Okay, I think that's what I want. That's correct. So let's say this is maybe 30 centimeters, or okay, I'll call it 0.5 meters. 0.5 meter, and let's say the area at the bottom is okay, maybe in meters squared. Is 0.2 meter squared area. That's my area at the bottom. I need something to describe the weight of the water, right? So I have the volume, and I can describe this using density of water. Let's say water has a density of 1 gram per cm cubed. Alright. Now, since I'm working in SI units, meter, okay, it will be more convenient if I have it in kilograms and meters. So the density of water will be 1,000 kilogram per meter cubed. Okay, use that more directly. But that is all the information I would need. You have the density of water, you have the height and the base area, so you can find the volume, and with the density you can find the mass, and with the mass you can find the weight, and the weight is the force, and the area is already given. Okay, so therefore we have all the information that we need to find the pressure. So let's see how we can now find the pressure. Okay, let's see. I am going to give these symbols some, give these quantities some symbols just to make things easier to write. So I'm going to let the density be given by this symbol rho. Now this symbol rho is like a rounded P. It's actually a Greek letter, and we pronounce this Greek letter. We don't call it P, we call it rho, as in R-H-O. That's the usual way to write the pronunciation. So in Greece, I guess, I don't know Greek, I guess rho is the in Greek corresponds to the R in English. Okay, so rho for density. Right. Okay. And I'm going to represent the 0.5 meter by h for height, right? And the 0.2 meter squared by a for area. Okay, we're almost there. So let's okay, now let's look at what we want. We want the pressure, right? Which is the force over the area. Now area we already have, so the next thing is to find the force. But what is the force? Okay, the force in this case is the weight. It's the weight of this motor. It's the weight. And from this information, how can we find the weight? Right. Can we find the weight? Now weight, we know, is equal to mass times acceleration due to gravity. Okay, maybe we are getting somewhere. Now acceleration due to gravity, let me just write this out for reference. Acceleration due to gravity g is 9.81 meters per second squared. Okay. So we know g, but what about mass? Mass, right, from the information that we have, we know mass is related to density, right? Mass is related to density. So let's, we're still kind of exploring a bit about how to go about doing this. Okay, so we are getting there. Now mass, okay, is related to density, but how is it related to density? Right, okay. Density, the density rho is related to mass by mass over volume, right? Mass over volume is the density. So that's density. That's mass related to, which is m. Okay. So if we know, okay, according to this formula, if we know the volume and the density, we should be able to find the mass. Now we do know the density, which is that. Do we know the volume? Okay, we have this area, we have this height. Okay, so yeah, we can just multiply them to get the volume. So it looks like we have a plan. All right, everything is now connected together. Let's backtrack. Let's see. We want the force. We know G, we must find the mass. To find the mass, we can use this formula, and we must find rho. We know rho, okay, so, and we must find V. And V we can find because V is area times the height. Okay, area times the height. Okay, that's it, the volume. Okay, right. So here goes. What I'm going to do is, this time, instead of putting the numbers step by step, right, to work out the answer, I'm going to rearrange the equations, all right, to obtain a final expression for the pressure before I calculate it, because this formula is going to come in useful, as we shall see. I'll let P be the symbol for pressure. So let me pull the whole lot together. Force is the weight. Okay. So area is A. Force is just the weight. Okay. So I'm just going to plow my way through this, and we'll sort things out as we see them. So pressure is force over area. Okay. Force is the weight. So it's the weight here in this case over the area. Okay. And the weight is mg. Weight is mg. So mg divided by the area. What is the weight? What is m? M. We'll come back to this formula. Now m can be this formula can be rearranged to make m the subject by moving v to the other side, or by multiplying both sides by v. So rho times v is equal to the mass, and v, we know v is the same as area times height. So let me put the whole lot together. So m would be rho times v, right? M. Okay. M would be rho times v, rho vg over a. And v is area times the height. V is area times height. So carry on. So rho, be careful of that this is rho and that is p. Okay. Rho is more rounded. P has a kind of a corner. So rho and v is a times h. A times h. Then there's the g. Whole thing over a. So now we see that the a here and the a here can cancel, and we have a formula for p in terms of rho, h, and g, and we know rho, h, and g, right? So yeah, so let me write down the final formula. The final formula is P is equal to rho g h. So we don't even need A. Alright, we don't even need A. You just need density, acceleration due to gravity, and height to find the pressure. So we have a formula. So now let's find the pressure. The density is 1000, acceleration due to gravity is 9.81, and height h is 0.5 meter. I'm running out of space, so let me clear up some of this too. So we can now calculate P, the pressure, by taking density, which is 1000 from there, times acceleration due to gravity 9.81, times the height, which is 0.5. And the answer is, right, let's see, so 5, 4, and 4.9. Okay, that's the answer. And see that we get all the places correct. Yes. Okay, and units for pressure. Unit for pressure. Let's do see if we can work this out from the formula for pressure. So pressure is force over area. We know that the the unit for force is Newton, and the unit for area is meter squared. So Newton over meter squared. So that's one way to write the unit. But for pressure has its own special name for its unit. So we can either write Newton per meter squared, that's fine, or it also has the name Pascal, right? P-A-S-C-A-L, Pascal. And the short form for that is just P-A, Pascal. Just a moment.